given us a couple of questions that we can throw out throughout the presentation so that you can stay engaged, and then we'll have a feedback poll at the end. So my name is Caroline Blake. I work for Lake Champlain Sea Grant as one of their staff members, but I'm actually going to pass the floor over to one of our interns, Paige Carpenter, who's going to take over the next couple of slides before officially introducing our presenter. So Paige, if you want to take it away.
Hi, my name is Paige and I'm an intern with Watershed Alliance. I'm a sophomore at UVM, and I'm going to be talking to you guys quickly about what Zuma Scientist is. So it is a series sponsored by Lake Champlain Sea Grant and UVM Extension, and also SUNY Plattsburgh's education program, Watershed Alliance. And this is a shared knowledge-based platform where people are here to learn about environment and economies of Lake Champlain Basin. And the goal is to increase awareness and knowledge of these watershed issues throughout Vermont and New York. And Zuma Scientist specifically is a scientist series created in response to the current need for more virtual programs.
Great.
So today we are going to be hearing from Stephen Smith, who is a fish biologist working at the U.S. Fish and Wildlife Service. Steve was born and raised here in Vermont near Lake Champlain in St. Albans, and he attended St. Mike's College and UVM, and he's been working on Lake Champlain full-time for the USFWS since 2007. So the topic of today is managing lamprey in the Lake Champlain Basin. So lamprey are a parasitic sea species that has invaded Lake Champlain over 100 years ago. And when the states of New York and Vermont and the U.S. Fish and Wildlife Service partnered to restore the populations of lake trout and Atlantic salmon, it became obvious that these lamprey populations were an obstacle for restoration. So these lamprey population management has been a priority for the restoration program beginning in the 1990s.
And so with that, we get to pass the floor over to Steve. Thank you so much for being here. We're really excited to hear your presentation. We've got a couple of people on the call, so you can, I'll do the stop share, and that way you can take over the screen, and I'm going to mute. And so I'm going to mute and turn off my video so the full presentation gets passed over to you.
Okay. I am happy to be here with everyone today. So, okay, I think maybe I've got this figured out.
Yep, it looks good on my end.
Okay, so I'll talk to everyone today here about management of sea lamprey in Lake Champlain. To start off, we're going to talk a little bit about the biology of the sea lamprey, just to help sort of put the management program into context a little bit. So quickly to start off, Paige mentioned that sea lamprey invaded Lake Champlain over 100 years ago. I just wanted to put this up here to show that sea lampreys were native to the Hudson River, and they migrated up the Hudson River. And when the Hudson River was connected to Lake Champlain by the Champlain Canal, they were able to gain access into Lake Champlain. Near that same time, they also were able to access areas further west in New York, into Lake Ontario, through the Finger Lakes, and eventually around Niagara Falls into the upper Great Lakes. So they were on their annual spawning migrations when they first made these advances into their non-native range. So I'm going to show you a few pictures here to start off. A lot easier to see and understand what we're talking about. These are sea lamprey adults. These are the fish that make the spawning migrations up tributaries, where they build nests in the gravel and deposit their eggs. They carry quite a number of eggs. Each female sea lamprey has somewhere between 50 and 100,000 eggs, depending on size. So you can see it doesn't take a lot of spawning sea lamprey to create a population. Once the eggs are hatched into these prolarvae and become larvae living in the stream, they're blind, and they're filter feeders at this stage when they're larvae, and they live burrowed in the sediments in the stream bottoms. We call these sea lamprey larvae ammocetes. This picture shows that these ammocetes live in the stream sediments for generally about 4 years. So you can see at the very bottom of the picture, I don't know if you'll be able to see my pointer or not.
Yep, we can see your pointer, so feel free to use that.
Okay, so here's an ammocetes that would be probably about 1 year living in the stream. This would be probably 2 years and 3 years before they go through a metamorphosis, a transformation into the parasitic phase of their life cycle. Okay, and when they enter the parasitic phase, they obviously become a parasite. They're no longer a filter feeder. They develop an eye and become more of a parasite or predator when they migrate to Lake Champlain to feed on native range in the ocean. I'm going to show a few pictures here quickly of what they leave behind after they've preyed on a fish. Here's a picture of a lake trout with a sea lamprey wound. You can see right behind the dorsal fin. Here's a lake whitefish from Lake Champlain with multiple sea lamprey attack marks. Another lake trout here. You can actually see this wound is a little older, but it's begun to heal, but it abdominal cavity, which will make it difficult for that fish to survive probably long term. Here's another salmon with a pretty serious wound, a few lake trout. But they also prey on, here's a picture of a times. That's much larger in diameter, and that happens very quickly. They make this change feeding on fish in about 15 months. It's estimated that up to 40 pounds of fish flesh in that period of 15 months. Just a quick illustration of that life cycle that shows, the vast majority of their lifespan is spent in the stream as a larvae. Parasite, a few months developing into an adult and going on the spawning migration up the tributaries, and just a short time as prolarvae, eggs and prolarvae in the stream. Sea lamprey are hindering fish population restoration with our program to restore native lake trout and Atlantic salmon. They're also, as you saw, with wounds on whitefish or burbot, walleye, and the sturgeon, having an impact on a larger species assembly. Done. We then set out to locate and count sea lamprey populations. We'll select appropriate control methods, apply the control, and then repeat the process. Continue to quantify the damage and make adjustments to our control selections and repeat. So quantifying the damage is basically done. I mean, for the most part, we're looking at the wounding rates that are found on our landlocked Atlantic salmon and lake trout. So every year in the fall, which is happening currently, our state partners were on the water today, netting lake trout near the Grand Isle Fish Hatchery. I was on the lake last night, out in a boat, collecting lake trout and Atlantic salmon and observing them for wounds, and at the same time taking length and weight data. Sometimes we even help some research programs that are going on around the lake with other samples that need to be collected. But you can see here that there was a time not that long ago where we were seeing marking wounding rates on lake trout approaching 100 wounds for every 100 fish that were processed. We have a goal to have lake trout wounding at 25 wounds per 100 fish. We've been sort of bouncing up and down a little bit higher than we'd like in the last 4 to 5 years, but our salmon wounding rates have stayed fairly close to our goal. Once we've quantified what the damage is, our program sets out to locate and quantify sea lamprey populations. So there's approximately 220 tributaries directly to Lake Champlain. This is ranging in size from the Winooski River, all the way down to a small stream, potentially even some small brooks that are, sometimes dry on some years. But there are over 220 tributaries that we look at, and that set of tributaries gets checked out at least once every 4 years by our assessment program. Out of that list, there's between 23 to 26 streams where sea lamprey are found on a regular basis. There's also at least 5 delta areas around the river mouths that have larval sea lamprey populations. And these streams, the population of larvae living in them can vary, obviously, quite substantially, size and habitat availability. We have some streams where we estimate there could be upwards of 200,000 larvae. Others, there may only be 1,000 or less. How do we sample those sea lamprey larvae? Well, in the streams, we have electrofishing backpacks where we're able to send a pulse of electricity into the water in the sediment that basically irritates the larvae, and they will sort of squiggle out of the sand, and we're able to stun them with another pulse of electricity and collect them. So we do this to all those streams that I mentioned before. On the delta areas, we have a boat that is set up so that we can do this electrofishing in water that's too deep to wade in. So there's a apparatus on the front of this boat that you can see here that gets lowered to the sediment, and we deliver a pulse of electricity, and any larvae that are affected by that come up through the hose to the boat on a vacuum dredge system. So that's how we do the larval assessment. And you'll see a stream survey will give us information on where on the stream larvae were collected and how many were collected in each site. And on a delta survey, we'll get information back on, where the lamprey are located, at what density, to allow us to plan from there. So, once we have the assessments complete, we have an idea for where lamprey are being produced, which streams have larger populations, and what the characteristics of each stream is. We can select an appropriate control method. So we say our three chief forms of control are mechanical control, chemical control, and biological control. I'll explain each of those in a little bit. So mechanical control is kind of, basically that simple, a mechanical device that we can put in that is in the river, or that we can put into a river tributary that physically stops the adult sea lamprey from making the migration to their spawning grounds. And those adults can either be trapped and removed, or in some cases just blocking them from getting to the spawning area is enough. A few examples here. We have some new developments for our program in some of our smaller tributaries. You can see at the top left and bottom right, those are structures that we have built here in Vermont on small streams, where we can put in these seasonal barriers to stop the lamprey migration and trap and remove the adults before they have a chance to spawn. Up in the top right, you can see this is a substantial barrier that was designed and constructed, that's actually on a tributary to the Pike River in Quebec. And this is fairly unique. We, again, seasonally install this barrier, and these barrels you can see on the front are actually float mechanisms, so that if the barrier gets plugged up and the water rises, these floats will trip a panel to fall, so the water can go downstream, so we don't have any flooding issues. Finally, over in the bottom left, you can see a permanent dam that was in place in New York that was retrofitted to become a sea lamprey trap and barrier on the Great Chazy River. So those are examples of mechanical control. Our chemical control program is we apply a Lampricide. It's called TFM in many rivers and streams around the lake. It's a chemical that's designed specifically to kill sea lamprey, and we meter the TFM carefully into the stream at low concentrations. You can see this top picture is at Lewis Creek in Vermont, and the lower picture is an application in the Hubbardton River on the southern part of the lake. There's also a Lampricide that we use on the delta areas. It's called Balicide. It's a granular formulation that gets applied with equipment that's calibrated to apply a specific weight per area in the delta areas where the larvae live. See this is our application boat, and it has a boom spreader across the back, and it's guided by a GPS system. You can see the guidance screen here in the top right. We use that on those delta areas I mentioned. Those are all located on the New York side of the lake. So I have a biological control in the presentation here. We don't actually use any of these methods in Lake Champlain. Some are still under development. There is a biological control called the sterile male release technique that's used in the Great Lakes. It was used more widely probably 10 years ago. It's been used more recently on a smaller scale basis in certain areas where they actually collect adult lamprey on their spawning migration, and they take the males and sterilize them with a chemical sterilant, and then they release the males back into the population to compete with any males that may be there that are not sterile. So we don't have that capability here in Lake Champlain. It's a larger scale type of a control method. But there's also the possibility that pheromone controls maybe, which in a pheromone is an attraction cue that's basically produced by members of the same organism. So sea lamprey produce a pheromone that attracts other sea lampreys, and it happens at multiple levels where adult sea lamprey can sense larval sea lamprey present in a stream and then select that stream for spawning, and adult female lampreys emit a pheromone that attracts males. So I'm sorry, actually that's backwards. The males that emit the pheromone that attracts females. So there's some possibility on the horizon that the pheromones could be an option for us in Lake Champlain at some point, but currently it's not an available option. So those control methods are part of our integrated pest management strategy to manage lamprey populations in the Champlain Basin, so that we can have further success with our restoration program for our native salmonids and restoration of our endangered lake sturgeon. Sort of to wrap up, we have a map just showing basically a synopsis of the control program currently, where we're operating our trapping program in the blue, and our Lampricide streams that are in red and yellow, with our delta control shown with the green arrows. We currently are basically rotating our control program around the lake in thirds and treating a geographic area all within the same year, in hopes that we can further reduce the lamprey numbers using this strategy. So that's all I had. Happy to take any questions that might be out there.
Awesome. Thanks so much, Stephen. We appreciate it. And so my computer cut out halfway through, not halfway through, just a little bit. So Paige, can you, if you have the ability to do, change you from the host to me to the host? If not, I'll have you launch the polls. But maybe while we're doing that behind the scenes, maybe Stephen, the first question I have for you, and kind of what we've asked all presenters, and we'll maybe go back to the polling questions, is how did you get into this field? And can you tell us a little bit more about your background to get to the position that you're now in, or passions, or whatever it may be in the professional world?
Sure. Well, it was mentioned earlier, I grew up here in Vermont as a youngster, spent a lot of time outside. I enjoy fishing and hunting. I had a grandfather and an older brother who were both also sort of interested in the same sort of things. That grew a little bit over time. When I got to school, when I got to college, thought it would be a pretty good way to spend your life in the outdoors. Ended up having an internship here with the U.S. Fish and Wildlife Service my last year when I was at St. Michael's in the biology program. Really enjoyed the work here, and I continued to work seasonally here for the Fish and Wildlife Service in Essex Junction for a few years before heading back to school and attending the University of Vermont, where I worked on a master's degree in fish and wildlife management. After that, I was able to land back here with the U.S. Fish and Wildlife Service in a permanent position as a fish biologist.
That's awesome. In order to be able to stay local, it's a hard thing to do in this neck of the woods.
I tell everyone that I am very, very fortunate to be able to work here where I grew up.
Great.
Tough.
For sure. All right. Well, I do have host capabilities now, so I'm going to launch those 2 quick questions that you have. That way people can see what they learned from the presentation. And we do have some questions coming in the chat box as well as the Q&A. So just for those of you that are joining, just a heads up, if you have the ability to put the questions into the Q&A box, that'll help us out. But Paige will be behind the scenes helping me out with the chat box as well. But I'm going to relaunch that first poll and see how you all did. So the question is, how did sea lamprey get into Lake Champlain? A, the zombie vampires put them there to drink their fish blood. B, a bird carried them from the ocean. C, they swam up Lake Champlain, swam up the Champlain Channel. Or D, they hitched a ride on Champ when he moved in. So I think polls are coming in. I'm gonna release it. And it looks like people got that one correct. They did. They swam up the channel, right, Stephen?
That's correct.
Oh, awesome. All right. And then I think we've got one poll right after this. I'm going to launch the second one. And it should say, how many tributaries does the U.S. Fish and Wildlife Service survey for sea lamprey in Lake Champlain? 2, 10, 200 plus, or 20? All right, they're rolling in a little bit here and there. All right, I'm gonna end the poll in 3, 2, 1. We've got some divided ones with just a couple of options. Can you refresh our memory, Stephen, on is it 20 or is it 200 plus?
We actually survey over 200 streams around the basin on a 4-year cycle to make sure that we can keep track of which streams the lamprey are in. They are unlike salmon. They do not return to the same stream to spawn every year, or when they spawn. They end up finding new tributaries at times. So we often find streams that historically did not have sea lamprey that all of a sudden have a population of sea lamprey. So we keep track of all of them, and there's over 200 around the basin.
Wow, that's impressive. That's a lot of work, and I know it took a lot of effort on your end to be able to make this meeting too. I know it's the fall busy season or the tail end of it, so thanks so much. All right, we've got some questions coming in from Colleen Hickey. Hi, Stephen. Do you know if there are many lamprey wounds on either the fish caught today in Grand Isle or the salmon that migrated up the lift in Winooski this fall? Very specific question.
Yeah, so I actually, I'm not sure what they found on the fish today in Grand Isle. I actually was helping the state at the trap on Grand Isle on last Friday, and there were certainly lamprey wounds still present on the fish. Hard to say for sure exactly what level we're at. I tend to think, based on what I saw last night, that the wounding rate may be a little bit lower on the lake trout this year, but we still have a lot more fish to process, so hard to say for sure. And I'm not sure about the Winooski River salmon. I actually haven't heard much about that.
Gotcha. All right. Well, Ellen Marsden just said in the quick Q&A. Good overview through the program. I have to go to another meeting, but nice to hear you in the presentation. All right, our next question is from Hannah saying, thank you for the presentation. I have heard a few years ago that several hundred mud puppies died as a result of the Lampricide. Was that a result of too high of a dose being used?
So yeah, that in 2009, when the Lamoille River was treated for the first time, there was several hundred mud puppies died as a result. We're still really not sure exactly what caused that event to happen. Obviously, it was related to Lampricide. Based on the dose requirements, we don't believe that it was a result of too high of a dose. There are other sensitive species to Lampricide. If it was really a case of a overdose, if you want to call it that, we probably would have seen some other fish that we really didn't see. So I'm not really sure. Sometimes there are other factors, you know, if there was other stress on mud puppies that year, it could have caused a greater mortality. So I guess the short answer is it's not really clear if it was some other confounding factor or potentially slightly too high of a dose, maybe the combination of a few things, but we didn't see any other mortality that would lead us to believe that it was, you know, strictly an application of too much Lampricide.
Understandable. All right, thanks for answering that one. We've got a question coming in from Nicholas saying, what's your opinion on the removal of the dam in Plattsburgh? It's been discussed in my classes about how it may affect the spread of lamprey.
Sure. So yeah, it will definitely affect the spread of lamprey. They will most definitely migrate up the river as far as they can if the dam is removed, which would expand their population a little bit further. We don't really know exactly what that would mean, but it certainly, I would say, certainly that their range in the Saranac River would be expanded if the dam was to be removed.
Gotcha. All right, Paige, can you help me as I kind of take over the screen again? I think that was the last question in the Q&A section, but anything come in the chat box?
No, there's just 2 questions there that they were mentioned before.
They were mentioned already. Okay, sounds good. Well, Stephen, it sounds like we'll wrap up here in just a second. Paige is going to kind of take over the, I'm going to launch a poll if I didn't just make it so that I can't. So please stick around for just a couple more minutes. That way we can do a feedback poll. This is our way of recording and kind of giving data to our own grantees. So let me just launch that feedback poll. And while I do that, I'm going to move on to the next slide. And Paige, do you want to teach them a little bit about the take-home activity? Again, it's just a quick YouTube. Oh, I guess I can do this one. So it's a quick YouTube video that I found online that Stephen approved, and just giving you some fun facts about sea lamprey, since he did give such a short presentation, which we asked him to do, which was great. It just goes a little bit more in depth with highlighting some key characteristics or where they can be found or what they look like and things like that. So if Paige, you can put that link to the YouTube into the chat box, that would be great. And then as people continue to answer that feedback poll, I'm going to let Paige take it away with what's up next.
So for our next Zoom scientist, it is unfortunately the last one. We're going to be hearing from Brittany Christensen, who talks about her work through the organization ADK Action and what she's done to address pollution of waterways by road salt runoff, including developing recommendations for reducing road salt pollution and promoting alternative dicing products, techniques, and best management practices to protect water resources. So if you want to sign up for this next webinar, you'll see the link coming up in the chat, as well as a link for all previous webinars that you can access through the YouTube channel.
Great. Well, thanks for reading that page. And Stephen, thank you so much for joining us on this. To highlight just quickly, you know, there's so much that goes into the position that you have and making management decisions, as well as, you know, having the best interest of all species in mind, while also trying to, you know, make the balance work as well. So with that, Paige has pasted in a couple of links into our chat box. Although, Paige, can you change it from all panelists to all panelists and attendees? That way everybody can see those, please. And that should give you a link to our YouTube channel where you can see previous presentations, as well as the link to sign up for future presentations. This is going to be the last one in this fall series in early December. But with that, we'll stop sharing, and Stephen, you're off the hook, so go and enjoy your afternoon, and thank you so much.
Well, thanks for having me.
Yeah, of course.
Great.